If you're just starting out in Unity, this tutorial should help you learn how to create basic movement with just a bit of C# code. Before jumping into the tutorial, I'd first like to thank everyone who's provided feedback on the series so far. You all have been awesome, and I'm really happy to see these videos are helping people learn game development. In the last video, we created a script that let our player move our bird with a sort of flapping motion. Now let's build on that simple movement mechanic and add some moving pipes for our player to dodge. In Unity, the first thing we'll do is create a new empty game object and name it pipes. To do that, simply right-click here in our hierarchy, go to Create Empty and left-click, and I'll rename this to pipes. This object will act as a parent and contain all the pipes we'll soon add to our level. Before we add anything to it though, let's make sure to reset our transform component. To do that, just right click on transform and left click on reset. Next, let's take the pipe that we created in part 1 and move it into our pipes game object. Left click on pipe and hold it down so you can see a little drag icon pops up, and I'll just pull it to where pipes is highlighted here, and I'll release my left click. To know that pipe is a child of pipes, you should see a tiny indent in our hierarchy to indicate it's the child within pipes. Nothing should really change here in the scene, but just like we reset our pipes, let's make sure that the pipe object is still set to 0. If yours is not, just make sure to right click and reset. Cool. Okay, because we want all the pipes to move towards our player, we need to start them on the opposite side of our player, then gradually move them to the left. So with our pipe still selected here, go to the transform component again, and as I mentioned before, it's important to keep everything aligned on the Z-axis. To be sure our pipe moves in a straight line, let's select only the X-axis. You can do this by either using the little red arrow down here in our move tool, or you can hover over the X position in your transform component until a double arrow pops up, like that. When it does, you can left click and drag it to the right. We want to move our pipe just beyond the far right area so it's slightly out of our player's view. To stick with round numbers, I'll just bump mine up to 15 on the X-axis here. While we're here, let's also create a couple more pipes to make a small level. To do that quickly, just make sure the pipe is still selected in your hierarchy and press Ctrl-Command-D to duplicate it. The new pipe should appear directly on top of the original pipe. To move it, simply make sure that our new pipe is selected here and move it a bit further to the right. I'll set my X-axis to 25. When we cover spawning our pipes with code in the next video, we can be more precise with spacing out our pipes. But for now, feel free to play around with it. Just make sure to always keep your Z-axis at 0. If you want, you can even change your Y-axis to add variety to your pipe's height. Just make sure that it's not so tall that the player can't fly over it. I'll leave mine at around 3. Feel free to make as many pipes as you want. The more you add, the longer your level will be. But because we'll be able to create an infinitely long level in the next video, I'll just add one more pipe before we hop into a bit of code. Next, let's create a new script by right-clicking on our scripts folder down here, going up to Create, and left-click on C# Script. Since this script will handle moving our pipes, let's rename it to Pipe Mover. Now with our parent pipes game object selected here, we can attach our script in a couple different ways. One way is to simply click Add Component and then search for your script Pipe Mover. And you'll see it appears here. Another way is to simply left click on your Pipe Mover script down here in your project folder and left click to drag it up under your transform component. You'll see a little blue line appears. That's just indicating you can let go and have your script attached that way. Perfect. Now to open our Pipe Mover script, let's just double left click it. If you watched the last video, what you see now should look pretty familiar. By default, Unity gives us these start and update methods. For this script, we won't need our start method, so let's just remove it. Also, we can delete this system.collections and system.collections.generic namespaces. We won't need those either. Cool, now let's create some movement. Like most things in game development, there are many ways you could handle movement in our game. One easy option is to simply move all of our pipes. Players may feel like they're flying through the level, but we can avoid moving the ground and keep our fixed camera view by simply moving our pipes towards the player. To do this, we just need to access the transform position on our pipes game object. So within our update method, let's type transform.position. This lets us get the current position of our pipes game object. Then type +=. Just like that. The += is commonly used in several languages to take a value and then add something to it incrementally. And because our transform position is nothing more than a vector3 value, we can change it by typing new vector3. Within our parentheses, let's type -5 for x, and then 0 for y, and 0 for z. This will add a negative x value, pushing the whole object to the left. This is exactly what we want. However, if we leave it like this, the movement speed of our pipes will be dependent on our frame rate. You might remember in the last video we saw how the update method is called once for every single frame. Keeping our code like this would mean the game would play totally different on a fast computer than it would a slow computer. For example, if computer A had an FPS or frames per second of 10, then our -5x value here would be called 10 times every second. This would produce a movement speed of -50 per second on the x-axis. Let's compare this with computer B that has an FPS of 5. If we take our same x value, -5, and multiply it by 5, we get a totally different movement speed of -25 per second on the x-axis. That's not what we want. We want every player to experience our game at the speed it was intended. So to normalize our movement speed, we need to use a constant value that isn't impacted by how fast the computer is. In this case, the value is time. Regardless of how many frames your computer can produce, 1 second is the same for everyone. And lucky for us, Unity has a built-in variable that calculates the time in seconds between the last frame and the current one. It's called Time.deltaTime. To use this value, all we need to do is multiply our vector3 by Time.deltaTime. Just like that. If we look at our two computers again and multiply each by Time.deltaTime, we can see that our movement speed per second is now identical regardless of the FPS differences. And that's it. Be sure to add your semicolon and save your script. Now we can test it in Unity. Now back in Unity, if we click on play, our pipe should move slowly towards us. We can still flap our little wings to try to get over each pipe, but now our player has obstacles they can dodge. Perfect. Now before we finish, let's do one last thing in our pipe mover script. I selected -5 for the x value just because that felt good to me during testing, but to make this easier to change, let's swap out this vector3 here with a variable. Like we saw in the last video, we can create a new variable by simply selecting a type and giving it a name. So let's use vector3 as our type, and we'll name it move speed. I'll space down a bit just to give my code some room. Next, I'll highlight my move speed variable and copy it with controller command C. Then I'll highlight where we said new vector3 and simply paste my variable on top of it. So I'll hit controller command V with new vector3 highlighted, and now you'll see move speed times Time.deltaTime. By default, our variable's value is still set to 0, so we need to assign it a value. Up until this point, any values we've assigned has been done directly within script. But to playtest our game faster, it's often easier to include access to a variable's value within Unity itself. Unless told otherwise, all variables are private by default. The words private and public just determine how accessible something is. For example, you can see our pipe mover class here is public. This means we can access it from other scripts, something we'll do a bit later. However, you may have noticed none of our private variables show up in Unity's inspector window. To make our vector3 variable show up here, we need to do something special to our variable. Right before we declare our vector3 variable type, we need to left click and type SerializeField. To do that, we need to do open and close brackets, and I'll type a space, and within those brackets, let's type SerializeField. Another option is to set this variable to public, but this opens up your script to unnecessary errors. It's best to keep variables and methods private unless you need access to them outside your current script. SerializeField is just a safer way to tell Unity that you want access to something within the editor. Now if we save again and go back into Unity, we should see our vector3 variable available in the Unity editor. Perfect. We can also see that it lets us assign values for X, Y, and Z simply by typing numbers into these boxes. To reproduce the exact same movement speed we created before, just type a -5 into the X box. If we click play again, you can see that the movement speed of our pipes is identical to what we had before. Except now, if we want to change our movement speed, all we have to do is change the value here in our editor. We don't have to touch our script at all. For fun, let's go ahead and double it. Now let's just click play. Great. Although movement in games can be handled in many different ways, hopefully you now have a basic understanding of just how easy it is to move pretty much anything. In the next video, we'll write a script to spawn all of our pipes and dynamically create infinite levels. We'll also be able to randomize our pipes' heights and directions. If you like this video, be sure to hit that little thumbs up button down below. It helps me out a lot and it's completely free. As always, please leave any comments or questions in the section below. Thanks so much for watching, and I'll see you in the next video.